right. Hi, everybody. How's it going? Hope you're having a great time here in Cannes. My name is Florian, and I'm head of product at Neon, the Ethereum virtual machine running on Solana. So at Neon, we're working on different products. But since the beginning of our journey, we always had one foot on the EVM world and one foot on Solana. And since there's still a bit of tribalism in Web3, some of you might be asking, hey, why is this Solana guy speaking at the biggest Ethereum conference in Europe? I mean, I would get the point, but this would also confirm the point that I came here to make, which is that we've been building too many walled gardens over the years. And we kind of force our builders and developers to pick side. We do have Ethereum and EVM chains on one hand, Solana on the other hand, tens of layers 1 and 2 everywhere. And despite the progress we've made with cross-chain protocols, we're still pretty far from the target, and many chains still feel like fragmented islands. So today I came to speak about how we can break that, how we did break that at Neon on a very specific case, and more specifically, how we can allow developers to build without borders, and so that they can onboard users without friction. But let's start with the builders. If I ask any Web3 developer in the room, what is stopping you from deploying application across different ecosystems? Well, it's not the ambition, it's not the lack of time or resources. It might be the lack of product market fit, because we're all looking for it in the space, but it's mostly the stack. Many chains still today operate like their own operating systems with their own languages, their own security models, their own mental overhead. And you could tell it's actually the same in Web 2, where you can develop an application in different languages, host it in different cloud providers like AWS, Azure, etc. But in reality, it's completely different. Why? Because everything in Web 2 is still very much interoperable with the HTTP protocol, for instance, and everything is standardized with the different runtimes. In Web 3, unfortunately, we're still a bit far from the target. We do have chains that operate, again, with their own dialects, with their own smart contract conventions, their own languages, their own wallet compatibilities, etc. So how can we break that? Well, we did work on Neon on that side, and basically, so if the slide is able to move. All right, so let me give you a very concrete example. If there is any EVM developer in the room that has been interested in deploying on Solana, well, I'm pretty sure this slide is very familiar to you, unfortunately. Too complex, not worth the rewrite, I will stick with what works. Those aren't just random Twitter quotes. They are the reality for many EVM developers. And why? Because, well, Solana has a completely different architecture compared to what we know in the EVM world. Stateless smart contracts, different tools, different security model. You have to learn Rust. And from an EVM perspective, this feels very different. So how can we break that? And how we did break that at Neon, well, that's the challenge we have to face, and specifically how we, to allow EVM apps to onboard Solana with breaking these borders. For that, we created a protocol, Neon EVM, and basically, this EVM protocol allows any EVM application to be onboarded on Solana via Neon without having to change 99% of your code base. So you have to simply use your day-to-day tool. We abstract the complexity, and you can easily create your application. So for EVM developers, You don't have to learn about Rust again. You don't have to understand how the Solana parallel runtime works, or the rent system, or the account model. No, you simply come as you would do in Solana, sorry, in the EVM world. You write your contract in Solidity or Viper. You just deploy your contract with your daily stack, like Foundry, Hard Hat, etc. And here we go, right? So that's for the EVM development part. But at the same time, we wanted to make sure that the user experience is not compromised. Why? Because as an EVM application, you basically want to get in touch with a new user base, a new audience, which is in that case the Solana audience. And for that, you want to interact with the audience natively. You don't want some kind of middleman in the middle, like having or forcing those users to use a different RPC, or bridge their assets, or use a different token. No. So to be fair, when we launched like like a year ago, we did this wrong. Early on, we worked some kind maybe like an L2 user experience. And after a couple of iterations, we also came back with this idea of creating a native experience where any EVM application can integrate native Solana wallets. What happens is that Solana wallets, or Solana users, sorry, are able to sign EVM transactions directly with their Solana wallet and use Sol as the gas token in that case. So we kind of break those barriers at the ecosystem and user experience level. So how does this work? Because we're in a developer session, and I will speak a bit about the technical aspects. Neon is not an L2, it's not a sidechain, it's a smart contract. And it's a smart contract running on Solana. So like any other smart contract you could interact with or write in the Solana blockchain. But it has a very specific role. It's an interpreter which is able to execute EVM bytecode inside Solana. In other terms, your EVM bytecode is executed inside the Neon smart contract, and this smart contract is executed inside the Solana virtual machine, like any other smart contracts you could have in Solana. And because of that level of compatibility, it unlocks a few critical things. The first thing is that the persistent data, what we call the state on the Ethereum, is hosted or stored into Solana accounts, and those Solana accounts are controlled by the Neon smart contract on Solana. Additionally, and again because it's compatible, we unlock access to the Solana syscall, and to make it simple, we unlock parallelization of transaction even for EVM transactions. So let's go one step forward and focus on, let's say, the core of the Neon EVM architecture, which is the proxy. Let's say you have your application with users connecting their Phantom or Solana wallet or EVM wallet, executing a transaction. This transaction goes to our Neon proxy, and before it even touches the Solana network, it does a couple of critical things. First, of course, it accepts the EVM-style transactions, and it then simulates a few things like what accounts on Solana will be used. It will calculate the compute budget. It will package everything into a valid Solana transaction before sending it to the Neon smart contract on the Solana blockchain, so it can be executed natively. Additionally, what was important, as I mentioned, the idea was to simplify and remove the complexity for developers because, again, there's a huge difference between the two models. And for that, we thought that it was very important also to add libraries, or to facilitate the developer experience. How? Well, we created these libraries where we remove all the complexities, as I mentioned, for EVM devs so that they can feel like using any other EVM chain, and they don't have to understand necessarily all the complexities. So with these libraries, you can handle Solana errors, but with EVM style. You can format Solana instructions like you would do, or handle the rent management accounts, etc., etc. But the most important part is, besides the technical aspect of it, well, why is it useful, and what use cases can we build? And that's where, after a couple of iterations and tests, well, we're currently working with different protocols, and we tested a few things. We have, for instance, DEXs, where we unlock a brand new audience and set of liquidity for DEXs, where any EVM DEX can connect native Solana wallets and basically get in touch with the Solana audience so they can sign EVM transactions or do swaps without having to bridge from Solana to any other EVM chain. So it facilitates the onboarding of the whole new crowd, the degen crowd also of Solana, to be familiar with it, and creates a lot of volume also on the DEX side. Another interesting case for lending protocols, well, accessing new pools of liquidity from the EVM world is something that is super interesting. We have this, again, composability feature where any EVM application built on Neon can easily access and interact with other Solana applications. So if you're an EVM lending protocol and you want to unlock a new liquidity or unlock the Solana liquidity, you simply call it from your EVM application and you're able to offer new yield sources to your users on the EVM side without having to rebuild entirely your application or having to understand the complexity on that side. Last point, a token launchpad. So we've seen a lot of launchpads starting recently and trying to compete with each other. The particularity in that case is if you're an EVM existing launchpad, you're able to launch SPL tokens from the EVM application. So any launchpad on the EVM side can have its own users launching new tokens also on Solana side. So we definitely broke the borders between those two ecosystems, and we facilitate, well, the user experience and the liquidity flowing between the two. I think I'm getting at the end of this presentation a bit ahead of time. But if you have any question, feel free to ask, and I will be happy to answer. Thank you. Yep.
Sí.
Thank you. I was curious, if you have your own EVM, it means it comes with an overhead in terms of processing time or gas cost. Can you give us some metrics about it?
Yeah, so of course we have to deal with the performance, and right now, with the latest changes we've done on the EVM side, we are slightly above the Solana native performance, but in like milliseconds above. So it depends, of course, what kind of logic you want to execute, because transfers are the simplest logic and we're extremely fast, like Solana. If you have heavier logic, because EVM transactions are way bigger than Solana transaction, we have to split this logic into multiple transactions, and this processing time takes a bit more time than a native Solana transaction. But we're still able to compete. And in terms of cost, which is the second part of your question, like the gas systems between the two models are completely different. You have to handle priority fees for lending the transaction in Solana. So this adds a bit of overcost. But again, the goal for us is to be very performing. And if you compare the cost of an EVM transaction, the price of it versus the EVM on Solana, you're faster and cheaper regarding those two aspects. Yeah.
Okay, thank you.
Thank you for the question. Okay.
Thank you for the presentation. Do you know any team which works on the product for trading or whatever real-world solution which you can talk about?
Reward solution?
Real world, yeah.
Real world solution. Yeah, I mean, we had, many EVM applications, DEXs, lending protocols, NFT platform, etc. That are already on as part of the ecosystem. But they were still using the old, or let's say the V1 of our product. And as I mentioned in the presentation, the user experience was not good. We were kind of like having this L2 user experience. I'm not criticizing L2s, etc., but we know the user experience is the biggest pain point. So since we onboarded native Solana wallets, which breaks basically this middleman feeling, we're now trying to onboard much more applications, and we're in talk with top-tier protocols to basically work on this integration. At the same time, we are, having, so this new feature has been launched in March, and we're now also, doing a lot of hackathons and boot camps, etc., just to increase the number of applications in the pipeline. But we do have some, and hopefully in the next 2 months, 3 months, you will see big announcements.
Thank you.
Yeah.
Thank you for the questions.
I just would like to know, when you say you're sort of translating the code, is that done by hand, automatic? Is there a scheme for it that does it automatic with AI, or how does that work?
So the complexity is, so there are two key pieces in the architecture. Maybe I can show it here in the image. You can see the Neon proxy and on the middle of the scheme or the diagram here, and you can see the Neon EVM program on the right side here. Those two pieces are very critical to in the architecture. Why? Because on one hand, you have an EVM transaction coming to the proxy, and here is where the magic happens, where we split the transaction into X smaller transactions. We basically translate them into a Solana transaction, and then we send those transactions in the Neon EVM program here, which is able to understand the EVM, what we call bytecode in that case. And from there, it reconstructs the transaction and then execute it directly on chain. So there is no AI, etc. It's just pure bytecode compatibility in that case, and a lot of mechanism to make sure that transactions are not dropping or failing in the middle. Why? Because again, the compute logic of the EV, or the size of an EVM transaction is 30 times bigger than a Solana transaction. So we have to split those heavy transactions into lighter transaction and still be very fast, and that's the challenge.
Okay, thank you for the answer.
Yep.
Do we have any more questions? Okay, since no more questions.
There's one there. Yeah.
Let's see.
So my question is about the token price. Did already Ethereum sold all their tokens or still not?
Token price?
Yeah, I'm worried about token price, and I'm worried about how Ethereum is selling tokens.
Yeah, so a couple of things. So from a legal standpoint, I'm not supposed to be speaking about token prices, but to not influence the price or whatever. But I can answer your question. The token is used for gas fees if you're using EVM wallets. In our case, for Solana wallets, it's not for that. Then you have the governance aspect, of course. But I mean, there are also new token usage that are in the pipeline, and hopefully once everything, the token economics are ready, etc., the usage will be increased. But besides that, it's all about, in the end, usage and onboarding new applications so that they can attract more users, and the more users we have, the more natural flow will happen, for sure. But yeah, I agree with you. Token economics in that stage are not...
Tokenomics, it's very important.
Of course.
Much price of token you have, your team is selling, so developers gain more salary, more developing, probably, I hope.
Yeah, I mean, it's the point for everyone. Like, the more you can onboard applications and users, the more supposedly there's a direct connection with the token price, for sure. Yeah.
Thank you for the speaker.
Thank you.